When you're not given all the sides, we can use the Pythagorean theorem to find the missing side or use the Pythagorean identity. So if we're given sine of theta is 5/6, we should draw a triangle. This is my right angle, and I'll just say theta is over here. So if theta is over here, we know that this is my hypotenuse, this is my opposite, and this would be my adjacent. So I know that sine is opposite over hypotenuse. So the opposite has to be 5. Now hypotenuse has to be 6. Right? That comes from 5/6. So now I can use the Pythagorean theorem to identify what the length of the adjacent side is. So I have a squared plus b squared equals c squared, where c is the hypotenuse. So I know the hypotenuse is 6, so this is 6 squared. And then opposite can go either one of these places. So I'm going to call this adjacent squared plus 5 squared. So adjacent squared plus 5 squared is 25. 6 squared is 36. Subtract 25 from each side. I get the adjacent side squared is equal to 11. In order to solve, I take the square root of both sides. And so the square root of a squared is a, that's the adjacent, and it's equal to the square root of 11. And so this is the square root of 11. And now I can identify my sine, cosine, tangent functions. Sine, we already know they gave it to us 5/6. That's a done deal. Cosecant is just a reciprocal, 6/5. Cosine is adjacent, which we just found, square root of 11 over the hypotenuse, which is 6. And the reciprocal is going to be 6 over the square root of 11. Can't leave it like that. We need to rationalize the denominator, so multiply top and bottom by the square root of 11. So we get 6 square root of 11 over 11. And that would be secant. Tangent is opposite over adjacent, so 5 over square root of 11. Again, rationalize the denominator, multiply top and bottom by the square root of 11. So we get 5 square root of 11 over 11. And last is cotangent. So I take my original here, 5 over square root of 11, and flip it, so it's square root of 11 over 5. All right, let's try that again with example number 3. This time, cosine is 9/41. So again, drawing a right triangle. And recognizing that cosine is equal adjacent over hypotenuse. So here's my theta. Here's my right angle. So this is going to be opposite. This is my hypotenuse. This is going to be my adjacent. So my adjacent is 9. My hypotenuse is 41. Setting up our equation, 9 a squared plus b squared equals c squared. Again, this is the hypotenuse, so 41 squared, and that's equal to 9 squared plus x squared. And 41 squared so I get 81 equal plus x squared equals 1681. Subtract 81 from each side. So we get x squared equals 1600. So x equals 40. So this will be 40 down here. And now I have my opposite, hypotenuse, and adjacent all set up. So sine is going to be opposite over hypotenuse, 40 over 41. 40 over 41. Cosecant is its reciprocal, 41 over 40. Cosine is adjacent over hypotenuse. We actually had that 9 over 41. So that means this is 41 over 9. And the tangent is going to be opposite over adjacent. So 40 over 9. The reciprocal is going to be 9 over 40.